Have you ever wondered if you can be offering a faster, less buggy application experience for your customers? With Raygun Application Performance Monitoring, you have all the information you need at your fingertips to find and fix errors and performance problems across your tech stack down to the line of code. Raygun makes it easy to monitor the impact of your performance improvements, quickly identify and resolve issues, and see how your code performs in the hands of your customers, saving you time, money, and sanity. I've personally used Raygun on my iOS apps, and when a user hits a crash, those crashes get centralized into one location. They get bucketed automatically. I'll get a call stack and an email with a line number where things were crashing. It felt to me that I got a gift from my customer in the form of a bug report that I could actually solve. Head over to raygun.com and try it out for yourself. That's raygun.com for a free 14-day trial. This is another episode of Cancel Minutes. Today I'm talking with Romain Goyet, the founder and CEO at NumWorks, which is really just a joyful calculator that I have come to love and my children love. How are you, sir?
Good. How are you?
I'm pretty good. So I have a 13-year-old and a 15-year-old, and the 15-year-old is taking physics and the 13-year-old is taking algebra. And when it came time for us to buy a calculator, we went to a flea market, like a resale place, and we found an old pink TI-89 or 83 or 80-something. I assume that's the year it was made, but I flipped it over and it said it was made in 2018. And I'm trying to reconcile why the calculator says 1983 or 83. And my son was like, I don't want to use your calculator. And I was like, oh man, I don't know what to tell him. What do I tell him about calculators in the world right now?
That's a very good intro. I mean, I never thought about putting it that way, but yeah, it's a very good way to put things out. So yeah, actually the TI-83 was, I think, like originally introduced in like 1994. So it doesn't have anything to do with the year. But the question still stands, right? Like, why would people still buy technology that's like 20 to 30 years old by now? And now, the true question is, it's okay to use tried and true products if you don't have a better alternative. And I think that's the problem here. And it's the very reason why I created NumWorks to begin with. I came pretty much to the same conclusion as you. And I just realized that people kept using TI calculators for lack of a better alternative. And don't get me wrong, they will give you the right results. They're not defective products. They're just really, really hard to use, especially by today's standards. Like if you go back in time in 1994 and you had to create an embedded device that would be able to do math, well, a TI-83 is pretty much the best thing you could have ever built. And the problem is they haven't evolved, even though technology has changed like dramatically. So about 4 years ago, I came pretty much to the same conclusion, and I figured, well, that's exactly what I want to be doing with my life. I want to create a new calculator that people would actually enjoy using.
Why is this something that didn't happen before? Like, why do I have a 4K Xbox and an iPad and an iPhone and a pocket supercomputer and this calculator? What happened? 20, 30 years went by. And no one decided this was a problem to solve.
That's a very good question. I don't have an actual answer to this. I only have like hypothesis. So one of them is that the market is actually much smaller, right? Because you will pretty much buy one calculator during your entire lifetime, and you will buy multiple phones, multiple gaming consoles. So when it comes to bigger companies, maybe they don't see the point of entering this product because they're going to sell so much fewer than phones, for instance. The other problem is if you want to build a phone, there's like a lot of software you're going to be able to reuse. When you build a calculator, you have to write lots of software that's custom made because you want to be like, if you take, for example, very basic calculations such as 0.1 plus 0.2 minus 0.3. Right? If you ask a standard computer to do this, like if you fire up a Python shell and you type that in, you will not get 0 as an answer. You will get something very close to 0, but not an actual 0. And that's totally fine for your average program, but for a calculator, it's totally unacceptable. So you have to write tons of, software for just this specific scenario.
There's a funny little controversy, and I say, of course, whenever someone says a funny little controversy, someone's like, no, this is the biggest problem in the world right now about the Windows calculator. Uh-huh. When you do something that's, 2 + 2 × 5, but you change the order, and there is a calculator that doesn't evaluate order of operations correctly because it does it in the order you entered it.
Yeah,
right?
Exactly.
And
so
it's 2020, and calculator in Windows still does that. But if you switch it into like scientific mode, it works fine. And no one understands that the reason it works like that is for compatibility reasons.
Exactly. And so actually, if you look at the most basic calculators, they can only display one result at a time, and you expect them to give you some result as soon as you type something in. So of course, they don't have a choice. They can't take priority in consideration, because if you go 2 + 3, they will need to give you an answer at this point. So they will have to tell you 5, and if you type times 3, it's too late. They can't do 2 + 3 × 3. The only thing they can possibly do is 5 × 3. Yeah. Now, regarding a software equivalent, I guess it's exactly like you said. It depends on what device you want to mimic, I guess.
Mm-hmm. So this TI that we got, we brought it home, and it was $5, and it's funny because it's $5 at the flea market, and it's like $100 or some huge amount of money. Mm-hmm. But if you do a teardown, there's not a lot going on inside them if you compare them to modern technology. And my son was quite frustrated with the calculator because he says it's not color and it's slow. And I was trying to explain to him how magical this calculator was, and he says, why can't I just use my iPhone? So then we started teaching ourselves about testing requirements and how you can't have your iPhone in the test because you could go and Google for the answer and things like that. And then I saw a tweet about NumWorks. I saw the calculator. They dropped into the Python shell, and I said, oh, I have to buy this. So I bought it immediately. How do you, though, get that allowed by a test? Because even when I tweeted about it and my excitement about this calculator, everyone's like, well, that's great, but you're not going to be able to use it on the SATs. Is that why TI basically had everyone locked down for 30 years?
No, that would be unfair to them. That's not what it's about. So standardized testing has some very strict requirements, which is totally understandable. But the requirements aren't you have to be TI. The requirements are open. And there's a list. And one of the items, for instance, is you can't do radio communications. If your device has an antenna, it's out of the game. And I feel like it's a really good requirement, because if you don't have an antenna, there's no way you're going to be able to communicate, and there's no way you're going to be able to cheat on a serious level. Mm-hmm. So essentially, when we built the calculator, we took the requirements of every single standardized test out there. That took us a lot of time, and we made sure we were at the intersection. And afterwards, it depends on the actual test. Some tests you just have to say you're compliant. You're hey, don't worry. You essentially tell your customers, hey, you guys, don't worry. You're good for this or that test. And for some tests, like the SAT, you have to pass a certification. So we sent a few calculators, I think it was a couple, to a certification center, and they looked into it, and they figured that, yeah, we did in fact match all of their requirements, and then they put our device on their list.
So it really sounds like it was just a matter of going through regulations, and it was a perception on the part of the market that this was a huge hurdle, and it was a significant hurdle, but you just pushed through it.
Well, yeah, I guess we play by the rules and we got approved, but I don't think there was any magic to it. Now, the big problem is if you want to actually be compliant, you have to pay attention. You can't just create a tool and figure, oh, by the way, people are also going to be able to use it on the SAT. That's not going to work. You have to start from the rules and build something that's compliant.
Now, you have built a modern calculator operating system, right?
Yep.
So is it true that the NumWorks calculator runs on a thing called Epsilon?
Yeah, totally. So we've pretty much built the entire thing from scratch. So we do reuse essentially what we do reuse is we took the libm from OpenBSD. Libm is a standardized implementation of floating point functions, like a floating point version of cosine or sine or exponential. And we reused an embedded Python interpreter called MicroPython, which is an amazing piece of software. But that's pretty much it. That's pretty much the entire code which we reused. Everything else we rewrote from scratch. And that's how we built Epsilon.
So the architecture is actually documented. It's interesting. I did not expect to go to a calculator website and start poking around and then find a section called engineering that explained the architecture of the actual thing. You'd have a custom GUI toolkit. There's a graphics engine. So you've got it very nicely layered.
Mm-hmm.
What is the, I will not pronounce this correctly, but Poincaré?
So it's a tribute to a French mathematician. It's essentially, we had to give a name to different layers of our operating system. So that was a pretty random choice. I mean, arbitrary.
That's your mathematical engine, though. Is
exactly
that where the BSD piece fit in?
Yeah. So yes and no. They're only a very small subpart of that software component. Like I told you earlier, if you ask the OpenBSD component to do 0.1 plus 0.2 minus 0.3, it will not give you the correct answer.
Right.
So we use it. Essentially, the reason we use that piece of code is to be compatible with Python, bug for bug. Like if you fire up a Python interpreter on our calculator and you do 0.1 plus 0.2 minus 0.3, you won't get 0. But that's on purpose because we want to match exactly what you would get on a computer.
All right, that makes sense. Mm-hmm. Okay, so you have a Python interpreter. You're allowed to be used on an exam because you have an exam mode, which I thought was a very clever way to solve that problem.
Yeah, so the exam mode is a requirement from some standardized tests. Not all of them, not the SAT nor the ACT for that matter. But in Europe, it's used in different countries. And essentially what it does, it will essentially wipe the memory of your calculator. But here in the US, the student it's okay if you press the reset button on the back, which, if you ask me, is pretty good because it does the exact same thing.
Because I remember, I think it's okay to say now, no one will come and take my degree, but I put a lot of notes on my calculator. I wrote a few programs. I may or may not have had a copy of Super Mario as well in the background.
Yeah. So from my perspective, of course, when it comes to designing a product, the only thing that matters is to be compliant with the rules, right? But my personal opinion on the matter is I don't think you can seriously cheat on an exam if you have a few notes here and there, right? And if it's not allowed, of course, you should not do it and you should just comply with the rules. But my personal opinion is that doesn't have that big of an impact. Now, if you could chat with random people, that would be a serious problem. But if you're just on your own, even if you manage to slip in a few notes, I don't think, especially for math and science in general, I don't think it's going to make a difference.
Mm-hmm. With cyber attacks on the rise, creating software that's secure is critical to every business's success. Yet 50% of organizations provide developers with security training only once a year, and much of this is often boring, unengaging, and not relevant to your everyday work. Veracode Security Labs offers real-world, hands-on challenges that gamify secure coding and put your skills to the test in as little as 5 minutes. You can select from dozens of interactive labs in the most popular programming languages. You can compete with colleagues and get instant remediation guidance, all at your own pace. Visit veracode.com/labs, that's VERA, code.com/labs today. You can start hacking and patching real apps right away with their complimentary community edition. One of the things that struck me, there's the industrial design of the thing. When you hold it in your hand, it feels like suspiciously light. It's a feather light. It's attractive. It's white. It's fresh. It's bright.
Well, thank you.
I mean, I know I'm gushing a little bit. I just think it's a great calculator. My sons love it. But then I found that I could just download it on my iPhone.
Sure.
Why are you so generous with this? The code is up on a Creative Commons license, not even MIT. It's up on a Creative Commons license. And when it launches on my iPhone, it launches like that. It's impossibly fast.
Yeah, it is. So regarding the openness, we figured that we were building a device that would let people learn, right? So learn math initially, but further down the road, they could also be interested in discovering and learning about the product itself, right? It's actually really interesting to see how a calculator performs mathematical operations. That was the initial reason. We figured, hey, we're in the education business, so we might actually go all the way and let people know how a calculator is made, because it's an amazing piece of technology. So that'd be great if people could learn as much as they could. And regarding the app, well, we're selling calculators, right? And people buy them. So why being greedy? It's a really great tool, especially when it comes to like distance learning. Like teachers love it. I mean, they have a free simulator. They can use it on the web. They can show it to their students, and it's so convenient. It's not gonna do any damage to our business, so why not doing it?
Don't you say it doesn't do any damage to your business? Interestingly, I put it on my son's phone. He tried it for a while. He said, "Oh, that's cool. It looks just like the calculator." And I said, "That's because it is."
Yeah, that's exactly what it is.
But he prefers the calculator. Prefers the tactile feeling of the calculator.
Yeah, exactly. So that's when we designed the calculator, it wasn't that long ago, and touch screens were already everywhere, right? And so technically, touch screens aren't allowed in a bunch of tests. So one of the reasons we didn't go for a touch screen was to make sure we were compliant with every single test out there. But another reason, because we tried a lot of stuff, and we realized that a touch screen is not so great for typing in general. Like if you look at a professional user, he or she will have a laptop, not an iPad. I mean, maybe an iPad with an external keyboard, but like an iPad is great for consuming content, but when it comes to generating content, well, you're much better off working off of a PC, right? And so touchscreens aren't that great for typing text, but they're terrible at typing numbers, because when it comes to typing text, you have a dictionary which you can use to make sure you're like correcting whatever the user is typing, but there's no way you could autocorrect 12 into 13. So when you're gonna do math, like an actual keyboard is so much better. So yeah, I would agree on this.
It's so interesting that it's open source as well. I don't think my children understand the significance of this. I'm literally up in your GitHub right now, and I'm watching some of your engineers. Looks like Emily and Leah doing the work here and going through and updating things, and I can see tests getting updated. I can see improvements. I can flash the firmware on my calculator, which is impressive.
Yeah.
This is clean C++ code. You actually go very specifically and teach people how to build it, and this is not like obfuscated code, which has caused a community to grow around it. When I tweeted about it, a high school student who I assume had a Twitter search set up jumped in and said, "Hey, we have a fork of this that we've made. It's called Omega." And it actually puts back features that it looks like you removed for test reasons, like symbolic calculation. Is that
true? So whenever you open some code, you will get some contributions. And some people have tweeted about it. It's actually a lot of work to handle contributions. And the hardest part of handling contributions is being able to say no. And some people will have different opinion of what should be in the software, which are very valid reasons. But eventually we have to make choices and decisions. And that's why you have forks around, like people who disagree with us on what a calculator software should be. Well, because we made the entire thing open, they have this fantastic opportunity to actually go ahead and build whatever they think is better. And usually, the one thing which is great is usually we get like pull requests in the first place. And unfortunately, some of the time we refuse them, and we try to justify why. And I hope we're making the right decision for the general public. But when you have advanced users, some of them have very legit reasons to want a different software. And having a fork is a really good alternative.
When I go and explore their code, I see them reference something called a model N100 and then a 110. Are there different models of the NumWorks?
So if you look at our code, you'll find the exact same thing. So we realized that for users, it was a pain in the butt to have to go through different modals. So officially, we only have one modal. And you buy a NumWorks calculator, and you don't have to worry about what's inside or what revision it is.
Right, now, not an 83 or an 89. Exactly. I don't even know the difference.
Exactly. So we just have this one calculator. Now in practice, well, of course, we're going to improve it, right? So we're going to improve the mechanical parts, and the mechanical parts is easy because you don't have to deal with software. But some of the time, we're going to improve the electronics, and on these occasions, well, we need to have a software that's slightly different when it comes to like a screen driver or a keyboard driver or whatever. We'll need to make some adjustments. So, and for legal reasons, we have to put the modal number on the calculator. But if you look at it, it's like in a super tiny font, like on the back. It's not something we advertise.
Yeah, so, that's a good point. Well, it's like my parents. One of them has an iPhone 6 and one has an iPhone 7. They don't know the difference. Exactly. They look the same. They can go into general settings about and maybe figure it out, but ultimately the reality is the same. Exactly. But certainly your homebrew community has gone and made Game Boy emulators and all kinds of things, which is interesting because it gets them excited about programming, and you're probably going to create a new generation of coders.
Exactly.
Because they hack their calculator.
It's funny we're talking about this because this morning I came up, I just discovered a Python script written by this kid who's like 12 or 13. He's like really young, and he coded a full-fledged Snake game. I mean, okay, Snake might not be the next AAA video game, but this kid
12?
Yeah, 12. I'm not kidding. And it's amazing. And I mean, I'm so proud. Like, he created this game on our calculator, and that made me feel really good.
That's really cool. Mm-hmm. The way that it runs online and on the phone, though, because it's clean C++ code, how are you doing that? Are you compiling it to JavaScript?
So that's a super geeky discussion, which I'm going to love. So for the phone version, we essentially rebuild the app for the native architecture of the phone, which is why it goes so fast. So essentially, it's a super small binary, and we leverage all the optimizations we make for an embedded calculator, and, well, they also benefit on a phone. So essentially, like, the entire app is like 1 megabyte, and it runs like super, super fast. That's what we do on iPhone and Android. So on Android, it's a bit more painful because like native apps on Android are Java initially. So we have to like break out of the Java world, and we use what Google calls the NDK. So it's a native development kit. It's made for high performance video games initially, but we reused this on Android. And on the web, so the web, that's an all other story. So we use this amazing software which is called Mscript, and it's a transpiler. So it takes all of our C++ code and rebuilds it, and it translates it to JavaScript. And it works amazingly well. So nowadays we could go for WebAssembly, and we probably will at some point. But the truth is, we're writing code for a super lightweight processor. So it has to be very efficient. So even though you lose some efficiency by going through JavaScript, eventually you'll run it on a PC or a Mac, which is an order of magnitude faster, so it will still be super snappy.
And folks that are listening and can't see this can go and explore the resources in the engineering section of the NumWorks website. Those hardware abstraction layers and the nice layering of this operating system is explained there. So, for example, Ion, the hardware abstraction layer, this reminds me of my time programming the Palm Pilot, where it's like set pixel and set brightness. And, you can just no-op the set brightness function on a browser and keep writing the code, and it just works. That's amazing.
Yeah, and actually, that's exactly what we did. Like, the set brightness just doesn't do anything on a browser.
So you have hardware abstraction layers for each of these things. And I really want to encourage the listener to go and take a look at numworks.com. First button on the page is try it online. It just goes boom. It's impossibly fast. And on the iPhone, it is really extraordinary. But you will want to hold one of these in your hand to really get the feeling of what you can accomplish. So you also sell them to classrooms. You can actually buy them in bulk, and
Yeah,
someone can
sure.
buy like a whole kit and like get the
Exactly.
entire team.
Uh-huh.
So those group orders, is this kind of stuff, are you finding it's US specific, or is the world getting involved in these calculators? Is the calculator blowing up all over the world, or is it primarily in the US?
Oh, that's a good question. So the market for graphing calculators is not really worldwide. It's kind of a first world kind of thing, to be honest. Because you have to be.
That was underneath my question.
Yeah, you kind of have to be able to afford the device in the first place.
Which is great because it's online or on their phones.
Exactly. So we do have an alternative for people who can't afford to buy one, and it's a free alternative. So that's pretty cool. And yeah, essentially, it's essentially schools in the US or in Europe who are actually buying the hardware calculator.
Mm-hmm. And the processor inside, like what's going on here, this is a microcontroller that is off the shelf, or is it custom designed?
No, it's not a custom design. It's pretty much off the shelf. It's actually a super interesting piece of technology here. So if ARM processors are very popular for being, well, in the iPhone and in pretty much every mobile phone out there, and in Macs nowadays. And the one place where they really shine is efficiency, right? Like number of operations per watt. And what the general public might not be aware of is that ARM has essentially 3 different variations of CPUs. They have the Cortex-A line, which is the most popular one, but they also have they have a Cortex-R, which is very specific. I'm not going to talk about this one. I think they went for the ARM trick. And they also have Cortex-M, which is targeted at embedded products. So you will find ARM CPUs in a microwave or in a car or in a calculator. And what is really cool about them is they are very, very, very powerful. Even though they're embedded, they're not as fast as the one you would get on a phone, but they're still insanely fast. And they use very, very, very little energy to achieve a pretty great computing power.
That's really significant. When I bought my TI 30 years ago, I think I also bought a 33 megahertz Intel processor. I think it was probably a 46SX or DX. And on this device, you're looking at a 216 megahertz processor with several years of standby. And it just charge it over micro USB. It runs forever as far as my children are concerned.
Yeah, that's pretty much what it is. So one of the reasons we went for this very specific architecture, and especially, so the calculator has static RAM, and static RAM is a very peculiar piece of technology. It's very rare. Like pretty much every RAM you usually have is dynamic, like the one you have in your phone or in your computer is DRAM. And DRAM is great. It's super cheap, super high performance, but it's got this one big drawback is you have to keep on refreshing it. Otherwise, it will forget about the data you put in the first place. And when I'm saying refreshing, I mean it. Like you have to refresh it every like thousands of times per second. And eventually that will use some amount of power. So if you take your mobile phone, you put it into airplane mode, so it doesn't do any radio whatsoever. And if you put it into your backpack and you wait like a few days, well, guess what? It will have run out of battery because it will have kept on refreshing its memory over and over and over again. And the RAM we have in here in our calculator is a static RAM, and this one consumes pretty much zero power whatsoever. And that's one of the reasons why it can stay powered down for ages, and you will just press the power button, it will wake up in the blink of an eye, and you will be exactly where you left it, even if it was a day ago, an hour ago, or a month ago.
The last thing I wanted to say, which is kind of 90% a compliment and a little bit of a question, is the last time I saw a company that had a design perspective and a well-organized website like this was when, if you recall, when Square came out, and then they were giving away those little credit card readers.
Sure.
It was
that was amazing.
There was a design aesthetic around it, and people wanted to hold the thing and touch the thing. You could have made this calculator. You could have put it on GitHub. You could have made it free, and it could have been ugly.
Yeah.
And it wouldn't have it wouldn't have happened. NumWorks wouldn't have happened. How did you decide? How did you, as a team, put a priority on this needs to feel good because we're going to be using this all day?
Yeah, I mean, this is essentially what's keeping us busy every single day. Like, how can we make a student's life easier? And that has so many implications. It starts with industrial design. And the reason it starts with industrial design is because that's the one thing we'll have the hardest time changing further down the line. So we spent insane amounts of time trying to come up with a device. And our initial brief was, we don't want people to be afraid by the calculator. We want them to think it's friendly. And that's really hard when it comes to a calculator because, well, it's a tool to do math, and math can be frightening, especially when you're learning and discovering the subject. So our initial motivation was, hey, whenever people are going to see that device, we want them to think, hey, even I could be able to use it. And further down the road, every single day, I spent, again, 2.5 hours this morning devising a new menu. And we keep on thinking, hey, how are we sure every single person out there is going to understand what the menu is about? And how can we make it easier for everyone to just get what it's about? So essentially, to answer your question, it's a lot of work, but it's super challenging and very interesting.
Fantastic. Well, the work absolutely shows. I appreciate you chatting with me today, and I want to encourage everyone to go and take it to numworks.com. You can take a look also in the Google Play Store and the iPhone Store. You can try it in the browser. And if you're a nerd like us, please check out the GitHub as well. There's just a lot of fun things happening. The calculator space is being innovative right now, and I'm just thrilled to see it. And on behalf of my kids, who are going to be thrilled to know that I'm talking with you today, I want to say thank you very much.
Oh, you're very welcome.
I've been talking with Romain Goyet from NumWorks. This has been another episode of Hansel Minutes.